A very good evening to one and all. Welcome to the fifth day of 1 week International Faculty Development Program on Research Methodology, Tools and Techniques organized by Nirvan University Jaipur and Inspire Research Association. Today we have with us a great academician, a renowned personality, Dr. Hitesh Parmar. Before I invite Dr. Hitesh Parmar, I would like to throw some light on his brief profile. Dr. Hitesh Parmar's academic and research experience spans over 15 years, making him an expert in his field. His educational background is impressive, holding a BE in mechanical engineering, an MBA in operations and marketing management, a PhD in management, and a postgraduate diploma in research methodology. Dr. Parmar's dedication to faculty development is evidenced by his impressive track record of conducting over 200 workshops and programs in data analysis. He is proficient in various software programs such as MS Excel, SPSS, Minitab, R, eViews, NVivo, Jamovi, SPSS, MOS, and Smart PLS, which allow him to conduct cutting-edge research and share his knowledge with others. Through his workshops and programs, Dr. Parmar has trained more than 15,000 participants, helping them to acquire the skills and knowledge needed to excel in their fields. Dr. Parmar has published more than 35 research papers in national and international journals of repute. Dr. Parmar has also co-authored 4 books, including Business Statistics, Production and Operation Management, and Research Methodology, which have been published by Himalaya Publications. In addition to his research and teaching duties, Dr. Parmar is also a content writer on research methodology for Baba Saheb Open University. Dr. Parmar is currently working on a research project on the destination image of the Statue of Unity. So very vast profile, sir. And we welcome you, sir, on behalf of Nirvan University and Inspire Research Association. Welcome, sir.
Thank you very much, sir, for a wonderful introduction.
Thank you, sir.
And we can start this session.
Yes.
I'm just opening my SPSS and I request all participants to open the file called Independent Sample T-Test. So we are just opening the file. I will share my screen. Let us open the file, this Independent Sample T-Test. The file is already been shared with you. Once participants will be ready, we can start. Right, so are you able to open the file, participants?
Yes, I have already shared with them in the WhatsApp group or email ID.
Yeah, so please open the file. Kindly confirm participants. If you are ready, then we will start.
Yes, sir.
Okay, thank you for confirming. Now we are starting it. So today we are going to discuss about the hypothesis testing, where we will be discussing the various types of the t-test, ANOVA, chi-square test also, correlation and regression also. So we are dealing today with lots of hypothesis testing part, right? If we see the brief of the hypothesis, then hypothesis is what? It is the assumption. Assumption regarding what? Your outcome of the research. Whenever you are conducting any type of research, then you are having certain assumptions, right? That if research is being conducted, then probably this will be your outcome of the research. And this is your research hypothesis. So when the term hypothesis comes into the picture, we generally think that it is the assumption, but assumption regarding the outcome of our research. Now, here we are dealing with this statistical hypothesis that is a little bit different from the research hypothesis, where a statistical hypothesis generally it is of the two types. The first, it is called the null hypothesis, and second one, it is called the alternative hypothesis. So can anybody tell me what is null hypothesis? Can any participant, you can unmute yourself, because it's very a small group, we can personally discuss also, right? So you can unmute and you can discuss what is null hypothesis.
Sir, hello.
Please.
Hello. Sir, when there is a no difference between variables, independent variables.
Okay, so Ritesh ji is saying that whenever there are two variables and then we are testing the relationship between two variables, then we are assuming that there is no significant difference or there is no relationship between these two variables. Now, null is what? Null and void means no relationship. Whatever the previous situation was present, at present also the same situation is going on. So we can say that there is no significant difference. And opposite of the null hypothesis is what? It is the alternative hypothesis. So when null hypothesis is true, automatically the alternative hypothesis will be false. And when the null is false, automatically the alternative will be true. So there are two hypotheses, null and alternative. Now as a researcher, we must have questioned that which hypothesis needs to be tested, whether we need to test the null or whether we need to test the alternative, which one to test. So this entire process of testing the hypothesis is being suggested by two statisticians, Fisher and Neyman. And they have suggested that we need to test the null hypothesis. Why null hypothesis? They gave a logic. What logic they gave? They provided a logic that whatever information we are having, that is all about the null hypothesis. We do not have any information regarding the alternative hypothesis. How? Say for example, if we say that there is a significant relationship or there is a significant difference, then the next question will arise that whether the difference is wide or the difference is narrow. What is the magnitude and strength of the difference? We don't know, because we have not tested it. So without testing, how can we say that whether the difference is narrow or whether the difference is wide? So whatever little bit information we are having, that is all about the null hypothesis, and on that logic only, Fisher and Neyman suggested that we need to test the null hypothesis directly. Now, when we are testing the null directly, then there will be definitely certain outcome. So there will be two outcome. Either number one, either we will reject the null, and second one, we will fail to reject the null. These are the two possible outcomes. Either we will reject the null or we will fail to reject the null. Now you may be thinking that why not accept, why fail to reject? So they gave the logic that in a court case, either the person will be guilty or the person will not be guilty, right? There are two situations. How the judgment will be given? The judgment will be given either the person is found to be guilty or the person is not guilty. So not guilty and innocent, there is a marginal difference, right? So similarly here, we can not say that we accept the null, but while writing your dissertation, writing your research paper, you need to report it like that. Either you reject the null or you fail to reject the null. But then how do you take this decision whether to reject or not to reject? So that depends upon the p-value. SPSS will give us the p-value, and on the basis of the
Excuse me,
p-value, we
sir.
need. Ha,
Excuse me, I have a question, sir.
please.
Sorry to disturb you, but I have a question based on null hypothesis.
Please ask.
Yes, sir. Yeah, sir. Basically, I am a research scholar from a university, State University of Haryana. My question is that yesterday we have a session in this same FDP, and there is a sir Ajay Kumar, Dr. Ajay Kumar Chauhan, and he stated basically कि null hypothesis हमें रखना ही नहीं होता है. जो null hypothesis है that is not for testing, and basically उन्होंने ये बोला था कि alternate hypothesis ही होना चाहिए, whether it's a research paper, whether it's a thesis. तो उन्होंने ये चीज बोली कि you have to not to take null hypothesis. तो अभी जैसे आपका आपसे बात हो रही है या आप जो
Okay,
बता
I
रहे हो,
got your
you are
question.
saying
Okay, fine.
yes, yes.
See, sir was talking about the research hypothesis, right? And research hypothesis will exactly look like your alternative hypothesis. So when you are writing your thesis or a research paper, you are writing your research hypothesis that there is a positive relationship between these two. So why positive? Because based on the literature review, you are coming with your research hypothesis. So research hypothesis is outcome of your literature review. But research hypothesis cannot be tested directly, right? So when you are framing the statement of the research hypothesis, it is perfectly okay. You report the research hypothesis. But for testing purpose, why statistical hypothesis comes into the picture? Statistical hypothesis comes into the picture because research hypothesis cannot be tested directly. So the statement of the research hypothesis are converted into null and alternative, and then we are testing the null and we are reporting the results. It is like that. Is it clear? So sir was right that you need to report the alternative, but alternative is exactly, it will look like your research hypothesis. Say for example, here the data set you are able to see monthly mobile bill and gender, right? Now maybe say for example, based on the literature review, we are commenting that who takes the more monthly mobile bill. Is it male respondent or is it the female respondent? Say for example, literature is the outcome. The outcome of the literature is like that the female respondents are having more monthly mobile bill as compared to male respondent. So this statement is what? It is your research hypothesis that female respondents are having more monthly mobile bill as compared to male respondent. Now this cannot be tested directly, so we need to convert them into null and alternative. Null will say there is no significant difference, alternative say there is a significant difference, right? And then we will be testing the null and then we'll report the results of the null hypothesis. It is like that. Is it clear?
Yes, sir, it is clear. But just my question is that कि हम null hypothesis को लेकर चल सकते हैं ना? It's not wrong कि हम null hypothesis को ना लें, because अभी तक मैंने बहुत सारे research paper thesis देखे हैं, तो there is some null hypothesis. It's not like that कि हम null hypothesis ले ही नहीं सकते. Whether it's thesis that are available on Shodh Ganga, there are so many theses of state universities, central universities, जहाँ पर null hypothesis को लिया गया है. But my question is that मतलब कि null hypothesis को अब latest time में या research papers
आप
whether
ले
it is a
सकते हैं
Scopus,
मैडम.
ABDC.
See what is the practice. I am telling you the practice. Depending upon the statistical test that you are applying. Say for example, you are applying structural equation modeling, right? Then the practice is to report the research hypothesis as stated by the Ajay sir, right? If you are reporting the t-test, ANOVA, then the practice is to report the null hypothesis. So for t-test, ANOVA, chi-square test also, and other non-parametric test also, the practice is to report the null hypothesis. For regression, again, the practice is to report the research hypothesis. So you can adopt the practice like depending upon the statistical analysis, you can either report the null or either you can report the research hypothesis, right? Is it clear, madam?
Yes, sir. We will take the queries at the end.
Okay. Fine. So here the null says that there is no significant difference, and alternative says that there is a significant difference. Now we are testing the null. We were discussing that how to take the decision. So software will give us the p-value, right? And p-value is what? It is called the probability value, and it depends upon your level of significance. Now say for example, if our level of significance is 5%, then 5% is what? 0.05. Then we need to compare the p-value reported by the software with the our level of significance, right? Say for example, the software has reported 0.23 as the p-value. Now what is our level of significance? Our level of significance is 5%, 0.05. So till 0.05 you can reject the null, and if the value is greater than 0.05 then you fail to reject the null. That is the standard rule. Okay, so now 0.23 is what? It is greater than 0.05. So what will be your decision? Your decision will be we need to reject, we need to fail to reject the null because the value is greater than 0.05. Till 0.05 you can reject it, greater than 0.05 you fail to reject it. Is the rule clear, everybody? If the level of significance is 5%. Is the rule clear, everybody? Okay. Now you will not unmute, but you will reply through chat. Say for example, my p-value reported by the software is, say for example, 0.001, and my level of significance is 5%. 0.001 is the p-value. What should be my decision? What will be my decision? We reject the null. Yes. Our decision will be we reject the null. Okay, fine. Very good. Now say for example, my p-value is 0.049. My p-value is 0.049. What will be our decision? We reject the null. Very good. Excellent. Suppose my p-value is 0.53. Suppose my p-value is 0.53. So we will write we fail to reject. Yes. In our usual discussion, yes, we can discuss that we accept the null. But while reporting in your dissertation or research paper, you please write fail to reject. So the rule is clear, perfect. Now we can move ahead. Now, first of all, let me briefly clarify the difference between Z and T. Z test and T test. Let me clarify. So Z test, it is called a large sample test. Z test is called large sample test. And if you want to apply the Z test, then there are two conditions. Condition number one is sample size greater than 30. This is condition number 1. And condition number 2, population parameter known to you. Now second one we need to little bit discuss. Population parameter means what? That population mean and population standard deviation. They are known to you. This is the condition number 2. If both conditions are satisfied, then we can apply z-test. Okay. Now imagine a situation, majority of the time you will have your sample size greater than 30, but you will not have access to your population parameter, right? This second condition you will not have. So statisticians are suggesting that in that condition, you can switch to t-test. In which situation? If a condition number 1 is fulfilled, but condition number 2 is not fulfilling, then you can apply t-test, but additionally, you need to check the condition of normality. So originally, a test called t-test was invented for a small sample. T-test was invented for a small sample. Small sample means less than 30. But then it was found suitable for a large sample also, greater than 30 also, but under a condition that the population parameter should not be known to us. If it is known to you, you may go for z-test. If it is not known to you, go for a t-test. So t-test can be applied for two situations as in terms of the sample size. Sample size less than or equal to 30, directly go for t-test. Sample size greater than 30, then ask additional question whether the population mean is known or it is unknown. If it is known, go for z-test. If it is unknown, go for t-test. Is it clear, everybody? Right? Just confirm through the chat box if it is clear. Very good. Right? And feel free to ask question in the chat box. I will take it at appropriate time without disturbing our flow. I will take it at appropriate time, but you may have question at any point in time. Just pose the question. Right? Don't worry. We'll take it. So this is clear. Fine. Now, t-test is for less than 30. That is okay, fine. And greater than 30, we need to ask the additional question. But fundamentally, when to go for t-test? So, if you want to compare the two means, then fundamentally you need to go for t-test. It will compare the two groups of the mean. Now, for example, I want, here we are comparing two mean, right? So we require two variables. The variable number 1, we will call it grouping variable. And grouping variable is what? Exactly two group, dichotomous. And the variable that we will be comparing, it is either interval or ratio. Nominal, ordinal, interval, ratio, scales of 4 types of scales of measurement. Is it clear, everybody? Are you aware? Nominal, ordinal, interval, and ratio. If it is discussed, it is clear, we can skip it. Yes, it is clear. Fine. So we require two variables. First of all, let us start with the independent sample t-test. Now, independent sample t-test, we require two variables. Variable number 1 will be two group variable. Variable number 2 will be either interval or ratio. Now, just check your data file. Grouping variable is what? Here it is gender two group variable, and interval and ratio variable, it is monthly mobile bill. Right? Monthly mobile bill is a ratio variable. So here in our data set, we are comparing monthly mobile bill across gender. Now, just type the situation where you can think that you are going to apply independent sample t-test. Just type in our chat box that where you would like to apply independent sample t-test. Right? No need to write the entire sentence. Just write, say for example, gender versus monthly mobile bill. Only the variable name. Right? Gender versus monthly mobile bill. So gender two group variable and monthly mobile bill ratio. So we are comparing exactly two groups. Are you able to understand? First of all, the variables that you are comparing must be either interval or ratio. Gender is independent variable. Yes, gender is independent variable. Why it is called independent sample t-test? Because the groups that you are comparing, they are independent of each other. That is the reason it is called independent sample t-test. So try to identify from your domain that where you can apply independent sample t-test. Just provide one or two example in our chat box. I require two variables. The first variable should be dichotomous variable, exactly two group. Sonia ji, age, generally it is not a dichotomous variable, right? I require two variable. First variable must be gender and income. Okay. See, when you will compare your or you will frame the hypothesis, one part of the section you will pick up from demographic, and second part of the section you will pick up from your main domain of study, right? Within demographic, try to avoid the comparison, right? I will compare gender and age, I will compare gender and income. Don't compare like this. Compare first variable you choose as your from your demographic, and second variable you choose from your main domain of study, and then you relate these two variables, right? A gender can be a dichotomous, COVID vaccinated and non-vaccinated, okay? So it can be a dichotomous, but what you will compare? Vaccinated and non-vaccinated, that is dichotomous, right? Gender versus level of knowledge. So level of knowledge, I am understanding that it is measured as a 5-point scale, so it is okay, right? You at least you require a 5-point scale variable here. Fine. So with this understanding, let us move ahead. I think now from application point of view, it is clear. Now let us move ahead. So first of all, as it is a parametric test, we need to check the normality. So we can click on analyze. This is the prerequisite, right? Before going for any hypothesis testing of the parametric test, we need to check the normality. So to check the normality, these are the steps: analyze, descriptive statistics, and explore. Analyze, descriptive statistics, and explore. Then in dependent list, transfer your continuous variable, which is monthly mobile bill. Click on the statistics. Give a tick mark to outliers. Click on continue. Click on the plots. Give a tick mark to normality plot with test. Also give a tick mark to histogram. And continue. Should I press OK? Or should I repeat the process? In statistics, we need to give a tick mark to outlier. And in plots, we need to give tick mark to histogram and normality plot with test. Right? We need to click to analyze, descriptive statistics, and explore. After clicking on the explore, this dialog box will appear. Transfer monthly mobile bill here in the dependent list. Click on the statistics, give a tick mark to outliers, continue. Click on plots, and then histogram and normality plot with test. And then continue and OK. Should I press OK? Okay, great. Just click OK and you will get your output. Let us see the output. Now, here the null hypothesis is what? For the test of normality, first of all, you need to go to this section called test of normality, the table called test of normality. Are you able to identify this test of normality? Did you get this table? Test of normality. Okay. Now, based on this table only, you will take your decision. Right. There are multiple graphs, multiple tables are available. Right. These tables are the descriptive statistics, other tables are. And this is the hypothesis testing. So this one is more reliable. Right. Say, for example, you will get certain symptoms. For example, the person becomes thirsty quite frequently, frequent urination, fatigue, right? These are the symptoms. So should we declare the person as diabetic or should we test this? So a blood sample and then report is the perfect, right? Symptoms are okay. And symptoms are indication, are giving certain indication. But test will confirm it. So this is the test of normality, right? Histogram and stem and leaf and other charts are okay, fine. These are the symptoms, descriptive. But confirmation will be done through test of normality. And if the test of normality, if clear-cut conclusion is not emerging, then you will see the additional statistics. Okay. Now, in the test of normality, two test of normality. The first one, Kolmogorov-Smirnov test and Shapiro-Wilk test. Both tests, they are separate from each other and simultaneously it is reported in the SPSS. Right. So you will observe two p-values. One p-value for Ks test, second p-value for SW test. Okay. Now SIG significant is the p-value. Now what is the p-value we are observing? 0.20 for Ks test and 0.063 for the Shapiro-Wilk test, right? And both the p-values are greater than 0.05. Now I forget to mention that what is the null hypothesis? The null hypothesis, the statement of the null hypothesis is written as for exclusively for the test of normality. It is written as the distribution is normal. How it is written? The distribution is normal for the test of normality. This is the statement of the null hypothesis. H0, what is the statement of null hypothesis? The distribution is normal. Now, what p-value we are getting? We are getting a p-value, both the p-value of point greater than 0.05. Right? In a comment section, somebody is asking, can we check Shapiro test as well, Shapiro-Wilk test and Ks test? Both the tests we need to observe the p-value. Right? And here both the tests, the p-values are greater than 0.05. So we need to take the conclusion that we fail to reject the null hypothesis. And fail to reject in our usual conversation, we can say accept. And it means that the statement of the null hypothesis is true. So what is the statement of the null hypothesis? The distribution is normal. So here we are confirming that the data or the distribution is normal. Right? So our conclusion is the distribution is normal. The data are normally distributed. This is our conclusion. So how you will confirm the normality for any variable? Look at the p-value. If it is greater than 0.05, confirm that it is normally distributed. Is it clear? Now there is a question, what if one test gives p-value less than 0.05? This situation we will see in our subsequent data files. Right? This is for if both the situations, if the tests are saying, both tests are giving the same result. If both are saying it is normal, conclude it as normal. If both tests are saying it is not normal, conclude it as not normal. But if one test is saying it is normal, other one says it is not normal, then we need to see the other statistics also that we will be checking in our next data file. Okay. Now, as after confirming the data is normal, now we can go for independent sample t-test. So let us go for it. To apply independent sample t-test, click on Analyze, Compare Mean, and Independent Sample t-test. Analyze, Compare Mean, and Independent Sample t-test. Transfer monthly mobile bill as a test variable. Transfer gender as a grouping variable. Right? Transfer monthly mobile bill as a test variable, transfer gender as a grouping variable. After transferring this gender as a grouping variable, click on define groups. Now what codes you have given, you need to type that only. Right? So here you need to type 1 and 2. Why 1 and 2? Because we have defined gender as 1 and 2. 1 as a male and 2 as female. We have defined our gender like this. So that is the reason we need to If our coding is 0 and 1, then we will type 0 and 1 like this. So 1 and 2, then continue, and then you will need to press OK. Should I press OK? Should I press OK? Yes. So this is our result of the t-test. Okay, now what is our null hypothesis here? So we are comparing the monthly mobile bill between male and female. So the null hypothesis will be that there is no significant difference in the monthly mobile bill between male and female respondents, right? The statement of null hypothesis is what? There is no significant difference in the monthly mobile bill between male and female respondents. So this is the statement of null hypothesis. This statement we are testing. The statement of null hypothesis we are testing. Now, see the mean value. Male 429.05, female 430.52. Just check the mean value. A slightly female monthly mobile bill is observed as compared to male, right? Slightly higher. But can we say that it has a significant difference or not? So we require a p-value. Now, from the statistics point of view, there are two formulas available for independent sample t-test. Formula number 1 is a situation where it is written table number 2, equal variance is assumed, and below that just it is written equal variance is not assumed. So from the statistical point of view, there are two formula. Formula number A for independent sample t-test if equal variance assumed. Formula number B, independent sample t-test if equal variance not assumed. Right, so there are two different formulas. So, but how do we know that whether in our case that if equal variances are assumed or equal variances are not assumed? Now, what is this variances and equality? So, say for example, you are comparing two groups, and one your objective is to compare the engine performance, for example. Now, one group you are identifying as a Alto, and second group you are identifying as a Ferrari, and you are comparing the engine performance. Should we compare? Are they comparable with respect to variability? No. Both cars are different, are performing in different segments. Their specifications are also completely different. So naturally, there will be a significant difference if you compare these two, right? There will be naturally significant difference. So try to avoid such groups. So that is the reason with respect to variability, the groups that you are comparing must be comparable. For example, let us take another example, that two age group you want to compare. And I am comparing 18 to 25 and 26 to 50. Now in 18 to 25, what is the years that I am considering? Only and only 7 years of variability. And 26 to 50, I am comparing 50 years of variability. There will be naturally significant difference, right? So the age, similarly, right, the variables that you are comparing, they must be comparable with respect to their variability. So that is the reason for t-test, they are giving us two different results. Result number 1 is for equal variance assumed, and result number 2 is for equal variance not assumed. These are the two different results available, right? Now, which one we need to follow? So for that, it is a test called Leven's test, F test. And by default, SPSS has given the result. So to choose a row number 1 or to choose the row number 2, we need to see the additional result. And this is for Leven's test. Is it clear why to go for Leven's test in between a t-test? So Leven's test will decide that you need to interpret the result of the t-test for row number 1 or row number 2. So here the Leven's test, again the null hypothesis is that there is no significant difference in the variability of the two groups. The null hypothesis is what? There is no significant difference in the variability between the two groups. This is the null hypothesis. Or in other words, equal variance assumed, right? If there is no significant difference in the variability means variance is equal. So equal variance assumed. That is the null hypothesis. Now what p-value we obtain here for Leven's test? 0.884. Is it less than 0.05 or is it greater than 0.05? It is greater than 0.05, right? So as it is greater than 0.05, so we fail to reject the null. So we fail to reject the null means statement of the null is true. What is the statement of null? There is no significant difference in the variability of the two groups. It means equal variance assumed is true. So row number 1 will be applicable to us. Is it clear? As the p-value is greater than 0.05, so we can say that equal variance assumed. So row number 1 is applicable. Now as equal variance assumed we are confirming, now you just forget the row number 2. Equal variance not assumed, you just forget the row number 2. Right? Now in the row number 1, equal variance assumed, the t calculated value is given as minus 0.379. What is the t calculated? It is the answer of the formula of the t statistics, right? T test. So t calculated, smaller the value, it is indicating that a very small difference between the group. Higher the value, it is indicating there is a higher difference between the group. And if the t calculated crosses the value of 1.96, then automatically your p value will suggest that it is having a significant difference. So there is a relationship between t statistics and significant value, p value. Higher the t calculated, smaller the p value. And if it is greater than 1.96, your p value will be less than 0.05. So here 0.37 value, absolute value 0.37. So the p value is greater than 0.05. 0.707 is the reported value. So we are concluding it as a no significant difference. As it is greater than 0.05, so we are concluding it as a no significant difference, right? So a null, we fail to reject the null and we are concluding it as a no significant difference in the monthly mobile bill between male and female respondent. And whatever difference we have obtained, that is just because by chance. Actually, with respect to population, the difference is not significant. That is your conclusion. Is it clear? So very quickly, if we understand the independent sample t-test, number 1, test of normality, see the p-value, it should be greater than 0.05 for both the test. After getting the green signal of the normality, run the t-test. If the Leven's test p-value is greater than 0.05, interpret the result of row number 1. If the Leven's test, the p-value is less than 0.05, interpret the result of row number 2. Check the p-value of the t-test. If it is less than 0.05, it as a significant difference. If the p-value is greater than 0.05, interpret it as no significant difference. That is the case. Now please open the file called dependent sample t-test. And meanwhile, if you have any question, just post the question related to independent sample t-test. And we will open the file of the dependent sample t-test. Right. If you have any question, just post it related to independent sample t-test, and at the same time open the file called dependent sample t-test. There is a question how to interpret the F is a ratio of the your variances. Right. F is what? It is the ratio of the variances. Larger variance divided by smaller variance. That is the F ratio. And based on the F ratio only, the value of the P value will be generated. For every test value, test statistics, there is a P value associated. Right. So final conclusion will be given by the P value only. But how the P value will be generated? Based on the test statistics only. So for Leven's test, the P value will be generated based on F value. For T test, the P value will be generated based on the T statistics. For KS test and Shapiro-Wilk test, again the P value are generated based on their W statistics, right? So every test, the test statistics is the main crunch, but it is again linked with your P value. So P value is the final reflection of your test statistics, right? So final conclusion, that is the reason we are making based on the test statistics, P value. Now the dependent sample T test. Dependent sample T test is your before after comparison. It is your before after comparison. So before situation, you are comparing the after situation. For example, your knowledge regarding the research methodology and statistics before this FDP and after this FDP, right? Suppose the test is being conducted, and before attending the FDP, you have given the test, and the same test you are giving after attending the FDP, right? And whether the difference is significant or not. So that is why before after situation. Now your after situation will always depend upon your before situation, right? Two variables you are obtaining. Just give me 2 minutes.
Kindly please wait. He is joining again. Please wait.
Okay, I hope I am audible.
Yes, sir. Yes.
Okay, let us start.
Okay.
Okay, so participants, we were discussing regarding the paired or dependent sample t-test. So dependent means your after data will depend upon your before data. That is called dependent sample t-test. Right? Your after score depends upon your before score. Right? Whether it increases or not, that is the main concern. Or whether, depending upon what type of data, sometimes it is desirable that the after score should decrease also. Right? But it depends upon your before data. So that is the reason it is called dependent sample t-test. And before and after, there is a pair of the observations. So in that sense, it is also called a paired sample t-test. Right? So in certain literature, you will find paired sample t-test. In certain literature, you will find dependent sample t-test. Right? So both the names are same. Right? The test is same. So what is the first step? Testing the normality. So let us test analyze, descriptive, and explore. Both the variables should be normally distributed. So let us transfer into the dependent list. Let us click on statistics, outliers, continue. Again, click on plot, histogram, normality plot with test, continue, and OK. Should I press OK? right? It is the same steps that you followed. And I've just click OK. So you will get your normality result. Who will interpret the result? Right? Just confirm through the chat. Is it normal or not? By looking at the test of normality, just conclude that whether it is normal or it is not. Okay. Any p-value which is greater than 0.05, then it will be normal. So what do you think? Let us discuss case test. Let us forget that we have the result of Sapir-Whorf. So according to case test, is it normal? According to KS test, is it normal? What do you think according to KS test? 0.038 and 0.036. These are the p values. Is it normal? It is not normal, right? 0.038 and 0.036, it is not normal. Any p-value which is less than 0.05, it is not normal. So KS test is saying it is not normal. Now let us discuss Sapir-Whorf. 0.16 and 0.057. Is it normal? Point 0.16 and 0.057. Is it normal? Yes, it is normal. Right. So based on Sapir-Whorf, it is normal. Based on KS test, it is not. Right. So these results are contradictory. Sapir-Whorf says it is normal, KS says it is not normal. So we need to check the additional statistics. Now what additional statistics you need to check? You need to check the skewness and kurtosis. Check the skewness and kurtosis. Where we will find the skewness and kurtosis? We will find in the table of descriptives. Descriptives. Just see the table of descriptives. Just above it. Test of normality, then you will find above this descriptives, table of descriptives, where you will find a separate value for before and after skewness and kurtosis. Are you able to find this skewness value? I am looking at this before. Skewness value, it is written here, statistics is 0.000. And kurtosis is minus 0.60 for before. For after 0.000 and kurtosis minus 0.58. Skewness is what? It is measuring the shape of your normal distribution is what? It is perfectly symmetrical distribution. Symmetrical means the mean value left side and right side, the curve is exactly same. It is symmetric. If it is not symmetric, then you may have more number of data on left side of the mean or on the right side of the mean, right? So more number of observations on the left side, it is called left skewed distribution. More number of data on right side, it is called right skewed distribution. So how do we check? If it is 0, then it is perfectly symmetrical distribution. A minus skewness value will indicate the negatively skewed distribution. A plus sign indicates a positively skewed distribution. Now here we have skewness value. We are not talking about kurtosis. We are talking about skewness. The value is exactly 0.000000. So based on skewness value, it is considered as a normal distribution. But there are thumb rule also. The thumb rule is that if the skewness value is in between -3 to +3, then the distribution can be considered approximately normal. If the skewness value is in between -3 to +3, then it is considered approximately normal. Right. So skewness value as well as kurtosis also the rule is same, -3 to +3. So just observe the value of skewness and kurtosis. 0.000 minus 0.60, 0.000 minus 0.58. So both the values are within the range of -3 to +3. So one more plus indicating that yes, we can consider along with the Shapiro-Wilk test, we can consider that the distribution is normal. So based on skewness and kurtosis and based on Shapiro-Wilk test, you can conclude that the data are normal and it is perfect to go for the parametric test. Is it clear how to break the tie, participants? Right, just additionally check the skewness and kurtosis and take your final call that whether it is normal or not. So it is normal. Now let us apply paired sample or dependent sample t-test. To apply it, we need to click on analyze, then compare mean and paired sample t-test. Analyze, compare means and paired sample t-test. Just click there. Now this number of productive cells we need to transfer as a variable one, and after we need to transfer as variable number 2. Automatically it will take. After transferring, you need to just click OK. Suppose you have more number of pairs, then automatically you can just select and then the pair will automatically you can add. Right, at present only 2 pairs are visible, but as soon as you enter the second pair, then the third will also be visible, fourth will also be visible. Like that, SPSS will automatically adjust. We need to just click OK, and this is the result of the paired sample t-test. Any difficulty in obtaining the result? Did you get the result? Now, what is the null hypothesis that we are testing here? The null hypothesis is there is no significant difference in the number of productive daily cells before training and after. What is the null hypothesis? There is no significant difference in the number of productive daily cells called before training and after training. This null hypothesis we have tested. What is the on an average before training? What was the performance? 3.40. After training, it has improved to 6. But whether it is significantly improved or not, for that we require a p-value. But with respect to mean value, yes, it looks like that from 3.40 to 6, yes, there is an improvement. But we need to confirm through the p-value. Only and only p-value will confirm it. Right? It is just the descriptive one. So p-value from where we will get our table number 3, paired sample t-test. And just observe the last column significant, 0.000. So it is less than 0.05. So we can reject the null. What is the null hypothesis? No significant difference in the productive cells before and after the training. So it is rejected. So there is a significant difference. Null is rejected. So our conclusion is there is a significant difference in the number of productive daily cells called before and after the training. Is it clear? As the p-value is less than 0.05, so you can reject the null hypothesis. Now, a significant difference doesn't necessarily mean that it is indicating improvement every time. Please remember, a significant difference means what? Before mean and after means there is a statistically significant difference. But it not necessarily mean that both are there is an improvement, right? Suppose if after sales, if the mean is less, suppose after training the mean is becoming 1.1, then also your p-value maybe it may go less than 0.05, right? So not necessarily a p-value always indicate significant improvement. For that, you need to check the mean value and then only you need to confirm whether it is according to your objective or not. Right? Less than p-value 0.05, it is indicating a significant difference. Is it clear, everybody? For example, let us take one more example. For example, a group of people joined the yoga classes. What was their objective? To reduce their blood pressure, for example. That was the objective. Now here, what is desirable situation? The desirable situation is that after mean should be less than before mean, right? After mean should be less than before. So in that case, a less than 0.05 of the p-value indicates that a statistically significant difference between after and before. But it not necessarily says that there is an improvement or not. So final judgment you will take, if the p-value is less than 0.05, then final judgment you will take by looking at the mean values, that whether it is according to your objective or not. Right? And generally what happens that whenever you are comparing the pairs, then if your objective is to see the relationship, which is not in our case, but by default SPSS gives you paired sample correlations by default. But our objective here is what? It is to look for the significant difference in the before and after. Whether are they correlated or not, if your objective is to check the relationship between before and after, then only you need to see the correlation. And then you can conclude that as the p-value is also greater than 0.05 and correlation is also 0.053. So you can say that there is no relationship between both pairs before and after. Right. So correlation is what? It is the pattern of relationship. Whether the increase and decrease, are they having the pattern of relationship? They are following the similar pattern or they are not following the similar pattern. But on an average, what is our objective behind t-test? That on an average, whether the difference is present between the before and after or not. Right. So here, yes, on an average, the difference is significant. So then finally, you can conclude that training is effective. Is it okay? Should we move ahead? Now, open the file one sample t-test. Open the file one sample t-test. One sample t-test is comparison of standard benchmarking value versus sample mean. What is one sample t-test? It is the comparison of some standard benchmarking value versus your sample mean. For example, the data here, it is showing that weight underscore gram. So there is a manufacturing process going on, and as compared to that, the weight of the product is 500 gram. Now, what is the condition? That the manufacturer is interested that on an average, what is the weight that the customer we are delivering to customer. So that is the concern. So some random samples were collected, their weights are measured, and it will be compared with the 500. So 500 is what? It is the standard benchmarking value. And against that standard benchmarking value, this sample mean will be compared. If you do not have benchmarking value, standard benchmarking value, then you cannot go with the one sample t-test. One sample t-test, again, it is the comparison of two mean only, right? It is again the comparison of two mean, but what are the two means? One is your sample mean, and second one is what? Your standard value. So before applying the one sample t-test, let us go for normality testing. Analyze descriptive statistics and explore. Weight underscore gram, just transfer into the dependent list. Click on the plots. Same histogram normality plot with test. Continue. Statistics, outliers, continue. And OK. Right? Same steps that you have already followed. What is the result? Is it normal? Or it is not normal? See the test of normality. Is it normal or it is not normal? P-value of Ks 0.000. P-value of Shapiro 0.065. So Shapiro says normal. Ks says it is not normal. So how to take a call? What should be our decision now? Okay, let us see the skewness and kurtosis. See the skewness and kurtosis value in the descriptive table, right? Skewness value 0.18, kurtosis minus 0.23. Both the values are between -3 to +3. So your decision is, yes, it can be considered as an approximately normal. See, if both are saying it is not normal, then don't see the skewness and kurtosis. Okay. If both are saying normal, then also don't see the skewness and kurtosis. Only and only in the case of contradiction, look at the skewness and kurtosis. Is it clear? If one is saying it is normal, another saying it is not normal, then only check the skewness and kurtosis and move ahead. Okay, so it is normal. Let us apply one sample t-test. Let us click on analyze, compare mean and one sample t-test. Transfer the variable weight underscore gram here. Test value. The test value here we need to put as 500. Every time, depending upon your data and your objective, the test value will be different. Every time your test value will be different. Here we are comparing from the manufacturer's point of view. So that is why benchmarking value, yes, every time your benchmarking test value will be different. So test value is 500 and just click OK and you will get your result. There is a question. If kurtosis and skewness also shown the values are not normal, then what should we do? Then we will declare that it is not normal. If kurtosis and skewness value, the values are not within the range, we will declare that no, it is not normally distributed. Again, my second question to you. If skewness says it is normal and kurtosis says it is not normal, then what will you do? Right? If skewness value is within -3 to +3 and kurtosis value is out of the range, then no, you need not to collect the data again. See, normality you may achieve or you may not achieve. If your data are not normal, that doesn't mean that you have collected poor data, right? If your data are not normally distributed, that doesn't mean that you have collected poor data, right? Say for example, you didn't like my lecture, for example, right? You didn't like my lecture. And when the feedback is being obtained, everybody will say that no, we don't like. So I will get extreme value, right? In terms of the either in a 1 to 5 scale, I will get only 1, 1, 1, 1, 1. So it is not normally distributed, right? Or everybody liked my lecture, 5, 5, 5, 5. So then also it is not normally distributed, right? So a data is not normally distributed. What does it mean? It means that it is not the uniformly distributed. The mean plus or minus 1 standard deviation, 2 standard deviation, 3 standard deviation, the distribution is not uniformly, but there is a skewed distribution. So there is some more intensity in the data, either more towards extremely agreement side or towards extremely disagreement side, right? There is the more intensity, and in that way you need to interpret it. And from the statistical point of view, switch to non-parametric test. If data are not normal, switch to non-parametric, right? I hope the point is clear. Yeah. Now let us interpret the result of one sample t-test. What mean we get here? 500.001261. Now what is the null hypothesis that we are testing? The null hypothesis is there is no significant difference in the sample mean and benchmarking mean. There is no significant difference between sample mean and benchmarking mean. That is the null hypothesis that we need to test. So sample mean we get 500.001261. So a p-value, table number 2, 0.049 on the border side, 0.049. We reject the null and it is concluded that there is a significant difference between a sample mean and benchmarking value. Our sample mean, which is 500.001, is statistically significantly different from 500. Why that happened? A very small marginal difference, but still it is saying a significant difference. Why it is happened? Because of the measurement, right? We have measured our data with respect to after point, there are 6 digits. So that is the reason SPSS has computed so minutely that a very small minor difference also became significant. Right? Because how did you measure it? You measure it with respect to minor values, 500.001261. So after point, how many digit you consider? 6 digit. So automatically SPSS understood that this is a extremely important variable, a very in a minutely the readings are being undertaken. The commodity is very extremely important. So in a 0.001261 gram also it is being measured, right? So a very small minor difference is also becoming significant. But suppose the commodity is of gold, then yes, it is significant difference for the manufacturer. But if it is detergent, for example, then a 0.001261 may not be significant for a manufacturer, right? But you have measured in such a way that automatically SPSS has considered is an approximately the significant difference. Is it clear, everybody? So here conclusion is your sample mean is significantly different from 500. Still the 5 minute is available. We can take one more test, that is ANOVA. Let us open the file ANOVA. Independent sample t-test we understood. How many groups we compare in independent sample t-test? 2 group, right? In independent sample t-test we compare 2 group. So there will be situation where we will have more than 2 group also, right? Always in research we never get exactly 2 group, but there will be situation where we will get more than 2 group also. Like age groups, maybe 18 to 25, 26 to 35, 36 to 45. So more than 2 group. Like income categories, maybe more than 2 groups. Like the number of cities, maybe more than 2 groups. Like the education categories, like the occupational categories, right? So we may have multiple variables where we need to compare more than 2 groups. And because of that reason, if you need to go for more than 2 group, then you need to go for ANOVA, one-way ANOVA. Is it clear application? Whenever you want to compare the mean, here also the same mean you are comparing, but more than 2 groups of mean you are comparing. Okay. Now again we need to take the normality call. So analyze descriptive statistics and explore. Transfer the variable price per pack. Click on plots. Give a tick mark to histogram. Normality plot with test. Continue. Statistics. Outliers. And continue. Same process. And click OK. Let us see the output. What is our result? Look at the p-values. Look at the p-values. What is the result? Yes, it is normal. Very good. Excellent. So we are declaring the variable as normal and it is appropriate to move ahead, right? Now let us go for ANOVA. Click on Analyze. compare mean, and now one sample ANOVA, one way ANOVA. Just click there. Your dependent variable is a price and your factor is city. Let us click on the options. Let us click on the descriptive. Let us also give a tick mark to means plot and continue. Now this tab called post hoc. You need to look at the result of the post hoc only if the significant difference is found. We need to see the result of the post hoc only if the significant difference is found. Is it clear? It is available for exactly identifying that if the difference is present, then between which group the difference is present. Right? So there are two options available. We'll go for this cafe, equal variance assumed, and we'll go for SCAFE. In the post hoc comparison, just give a tick mark to SCAFE and continue and OK. And this is your ANOVA result. First of all, did you get the result or not? Did you get your result? Should we move ahead? Okay, what is the null hypothesis here? No significant difference in the price per pack of biscuit among 4 different cities. There is no significant difference in the price per pack of biscuit among 4 different cities. This is the null hypothesis. If we look at the mean value, there is a slightly variation among the mean values, but is it significant? We need to check at the ANOVA table. Now in ANOVA table, see, every calculation is linked with the other one. Right? Sum of square divided by df, degree of freedom, you will get a mean square value. Mean square, if you get the ratio 7.01 divided by 1.75, you will get the f value. And related to f value, you get the significant p value. Higher the f value, lower the p value. Right? So the p value is 0.022. So 0.022 means yes, it is significant. So there is a significant difference in the price per pack of biscuit among 4 different cities. But between which exactly cities? That is not clear from ANOVA. So that we need to check from the post hoc test. Now in the post hoc test, just look at the significant column. The column of significant. 0.64, we need to check that whether this value is less than 0.05 or greater than 0.0. So 0.64, 0.026, yes, it is less than 0.05. So whenever a p value is less than 0.05, you need to conclude it as significant difference. So 0.026, it is less than 0.05. So Kolkata and Delhi, there is a significant difference. Is it clear? You need to just check a value which should be less than 0.05 and see that which pairs are having a significant difference. So 0.026 is less than 0.05. So yes, Kolkata and Delhi. Again, if we move ahead, again we found a value 0.026. But it is the same pair, Delhi and Kolkata. and rest of the p values are greater than 0.05, no significant difference, right? So only in the case, though there is a significant difference in the price among the city, but only in the case of Delhi and Kolkata, the difference is significant. That should be your conclusion. Right? So because of the time limitation, we have to stop here. Right? Whatever is possible within the time, we try to cover the number of tests.
Thank you so much, Dr. Hitesh Parmar, sir.
Thank you, sir. Thank you.
Sir, it was really a wonderful hands-on presentation from your side. Everyone is very happy. We can see in the chat box also. If still you have any question, participants, you have 2 minutes. You can ask to Dr. Hitesh. Any question you can ask, please click on raise hand icon. I will unmute you. If you want to ask any question related to today's session, you may ask. Lots of thank you so much, sir, in the chat box, sir. So everyone is, I think.
Thank you, participants. Thank you very much.
Everyone is satisfied, sir, today. So thank you so much. And before I invite Dr. Aarti for formal vote of thanks, again, I request all of you to please switch on your videos for the screenshots. Most of the times I can see not everyone switch on their videos, so they missed in the screenshots. So I request everyone to please keep your video on. Yeah, thank you so much. So I request and I welcome Dr. Aarti Chopra, Joint Secretary, Inspira Research Association, to give formal vote of thanks on behalf of Nirvan and Inspira. Dr. Aarti, please unmute.
Very good evening to each one of you. And this was the 5th day of our International Faculty Development Program on Research Methodology, Tools and Techniques, being organized by Nirvan University, Jaipur, and powered by Inspira Research Association. So on the 5th day, we had a privilege to listen to Dr. Hitesh Parmar, who is an associate professor at Postgraduate Department in Business Management, Sardar Patel University, Vallabh Vidyanagar, Gujarat. सर आपके लिए तो क्या ही कहें, क्योंकि जो व्यक्ति इतना पहले से ही प्रसिद्ध हो, पॉपुलर हो, उनकी प्रशंसा में हम और क्या कह सकते हैं. बट ऑल व्हाट आई कैन से इज it is the most difficult or the scary part of research, that is the quantitative tools. So the researchers, when they enter, when they start doing their research, they get very scared of quantitative tools, because one thing is they are mathematical, they need a lot of analysis. Secondly, it is very difficult to select that which particular tool will be suitable for what kind of sample size and what kind of objective. How beautifully you have explained everything to our participants. Rather, it was not a session, but a hands-on workshop. So practically and hands-on experience you have given to our participants. I am sure that your expertise and clear presentation have really enhanced the confidence of the participants to choose the quantitative tools effectively. And sir, we can see that how the chat box is flooded with lot of gratitude and appreciation for you. I am so thankful on behalf of the organizers to Dr. Hitesh Parmar for accepting our invitation and giving such a wonderful presentation in an effective way, in such a precise way. All the participants have immensely benefited with your session, sir. Thank you once again for accepting our invitation and enlightening our participants, sir. Thank you so much.
Thank you, madam. Thank you very much.
Thank you so much.
Thank you, Modi sir.
Thank you, sir.
For inviting me, and thank you all participants.
Thank you, sir. Indeed, it was a really wonderful presentation from your side. Thank you, sir. And tomorrow, I've already shared the feedback link in the chat box. You can copy. If you have not received, I can again send. Please copy the feedback link. And tomorrow, the session will be given by Professor Manvinder Singh Pahwa, and I think he is coming. He is coming to join for some announcement for tomorrow's session. So Professor Pahwa sir is joining very soon. So please wait, participants. Thank you so much, Hitesh sir.
Thank you, sir. Thank you.
It was
Yeah.
a wonderful session, sir.
Thank you.
Thank you so much on behalf of the organizers, sir. Thank you. Participant, please wait. Professor Pahwa sir is joining, tomorrow's resource person. Just wait. Just wait. Actually, he is in the car, so he's trying to join. He wants to make some announcement for tomorrow's session. So those who want to listen, please wait. Actually, there is some network problem from Professor Manvinder Singh Pahwa's side. He just want to say that he will take hands-on exercise tomorrow with SPSS software. So I request you to please download SPSS, and I will share some files with you very soon when Professor Pahwa sir sent me. So I will share the files. You can download and join the tomorrow's session. So thank you so much and good night. Sorry for the delay. Thank you so much, all the participants. We will meet tomorrow at the same time.